Hi, this is section 11.4, and this has a lot of three-dimensional shapes to it. So that's why I'm going to use PowerPoint instead of trying to draw all those shapes. Now, some of the shapes that we're going to be talking about have very specific names. So I'll tell you what, let's just go right into it. And that's going to be a lot of what we focus on, is a lot of terminology in this section. So let's see here. Let me go ahead and share my screen. My entire screen. Share. Okay. Open up that PowerPoint and we will just start playing this from the beginning. All right. So this is three-dimensional geometry. We're going to talk about things like simple closed surfaces, polyhedra, how to draw them, and things like that. So a simple closed surface. We talked about a simple closed curve back a few sections ago. Now we talk about a simple closed surface. It has exactly one interior, no holes, and is hollow. Okay, so what is something that's not? So these are all examples that are simple closed surfaces. So look at the ones at the bottom. Those are not simple closed surfaces. See how they have a hole in there? And the one down here on the right, that kind of hourglass looking one, that one has two interiors. So that's what makes this one, those two not simple closed surfaces. All right. A sphere. Now a sphere is basically a three-dimensional circle, right? Just like a circle is the set of all the points in the plane that are equidistant from a fixed point called the center. A sphere is the set of all points a given distance from a point, not just in one two-dimensional plane. Now we're talking about in space. So a solid, the set of all points on a simple closed surface together with all the interior points. And a polyhedron, a simple closed surface made up of polygonal regions. We call these faces. The vertices of the polygonal regions are the vertices of the polyhedron, right? So remember, the vertices are where the sides of the polygon, remember polygons are made of line segments, where those meet, that's called a vertex. The plural is vertices. The sides of the polygonal regions are called the edges of the polyhedron. So let me show you some pictures here. So up top, we have some examples that are polyhedra. And then we have examples down there that are not polyhedra. So let's talk about why those are not polyhedra. So tell you what, let's go back. Simple closed surface made up of polygonal regions, as in polygon, as in line segments. So sphere, not line segments. Cylinder, nope, not line segments. All right, the other two look like they're going to be line segments, but let's go back. They're not simple closed surfaces, right? Remember, simple means it doesn't cross itself, right? Closed means it starts and ends at the same point. So those do not meet that criteria. So a type of polygon we're going to start with here is a prism. It has two parallel congruent bases. Those are the upper base and the lower base. Like that, so you can see. The sides are called the lateral faces, and those are parallelograms. Now, you might be looking at that and saying, no, that's not a parallelogram, that's a rectangle. Remember, a rectangle is a specific type of parallelogram, right? With all right angles. So if you take a parallelogram, give it some right angles, blammo, that's a rectangle. So in this case, this prism is called a triangular prism because they're named according to the shape of their base. And the base on this one are triangles. We have an upper base and a lower base. So the sides are what we call the lateral faces, and the upper and the lower parts are called the bases. So a right prism is basically like a right angle, right? A right prism is standing straight up. The base meets the lateral faces at a 90-degree angle. and the lateral faces are rectangles, right? Right angle. Oblique means it's all kind of, kind of slanted over. So it's not perpendicular, it's not right. So when I say right, I mean as in right angle. So you can see the examples there. We have a triangular prism. You can tell because it's a triangle on the bases, those blue parts. The quadrilateral right prism, you could also call that a rectangular prism, right? You don't have to be so generic about it. Call it a quadrilateral right prism. The hexagonal right prism, because there's a hexagon as the base. And then we have a hexagonal oblique prism. So it's a hexagonal prism, but the bases are not directly above and below each other, right? They are in parallel planes, but they're not right angles there. A pyramid, that's another type of polyhedron, and it's a polygon as the base, and then a point not in the plane of the polygon, it means a point somewhere else. That point is called the apex. Okay? The sides or the lateral faces of a pyramid are triangles, whereas in a prism, they were parallelograms or rectangles if it was a right prism. Pyramids are named according to their base. You can have in this case, a triangular pyramid. You can have a square pyramid, which you can see in this picture. You can see a pentagonal pyramid. But the thing that pyramids have in common is that they have this base, they have triangular lateral faces, and they have this apex, this point that's not in the plane of the base. Now that square pyramid looks kind of janky, doesn't it? I kind of dig that, they didn't just sit it on its base. If they showed you, hey, you know what? Nobody says it has to sit on its base. The base can be kind of, over there. The truncated polyhedron. Truncated just means that some of it got cut off. That's all it means. So the first picture is a truncated square pyramid. So basically they took a square pyramid and sliced off the top. That's what truncated means. And I get, if one or more corners of a polyhedron is removed by intersecting plane or planes, that's a really super complicated way of saying that you just gotta slice some of it off. The truncated cube, you can see where that little corner was kind of sliced off there. Think of it like a block of cheese or something. You just kind of snuck a little piece off there. Truncated prism, so you can slice it parallel to the base. You can slice it kind of, however you want to truncate these things. Regular polyhedra. Now remember, when we say words like right and regular, they have a certain grammatical connotation, right? When we say, oh, that's a right triangle or that's a right polyhedra, you think about the word correct. You got to think different in math. When we say right, we typically mean like a right angle. When we say regular, remember, polygon had all sides congruent. So regular polyhedra, so we have a convex polyhedron and concave. We talked about these in terms of polygons, two-dimensional things, where convex, remember, it kind of flexes out, and concave caves in. But we still have that same definition about any 2 points in the interior can be connected by a line segment that is completely contained in the interior. So same definition as before, now just expanded to a 3-dimensional figure. A regular polyhedron is a convex polyhedron whose faces are all congruent regular polygons. Okay, the number of edges that meet at each vertex is the same for all the vertices. These regular polyhedra are called the Platonic solids. They're named after the philosopher Plato. So we have the cube that is made up of all squares. We have the tetrahedron, also known by its friends as the triangular pyramid. We have an octahedron that's made up of all triangles, all congruent triangles. Then we have the dodecahedron. You can tell that that's a bunch of pentagons. And then we have the icosahedron. Look at that bad boy. Those things are impressive. All right, so the polygon that makes up the tetrahedron, octahedron, and icosahedron, you can tell, is all equilateral triangles. Okay. For the cube, the squares make up the shape, and then for the dodecahedron, it was a bunch of pentagons. Now, if you wanted to construct those regular polyhedra in a normal classroom setting, that would be an activity that I give to you guys to do. It's actually pretty cool to do with kids as well. If you're doing some geometry, these are what's called nets that you can cut out and then you can fold together to make those Platonic solids. Right? So it's actually a pretty cool activity to do, especially if you have like some creative kids that maybe aren't really into math, then this is a really good opportunity for them to showcase creativity while learning some stuff as well. So. All right, cylinders and cones. Now these are simple closed surfaces, but they're not polyhedron because they're not made up of line segments. Okay. Formed as a segment AB parallel to a given line traces a planar curve. Line L traces a planar curve other than a polygon. I'll tell you what, sometimes these definitions that this book gives is a hot mess. You go ahead and just know that future PowerPoints that I may just bail on this. I'm trying to kind of stay with what the book is saying, but dang, it's making it hard when it says crap like that. All right, here's a cylinder. A cylinder is like a soup can, right? You got parallel bases that are the exact same shape, they're congruent. And then you've got this kind of lateral surface that extends from one base to the next. We can talk about having a right cylinder or oblique. Right? Again, right meaning 90-degree angle, going straight up and down. Oblique meaning kind of kicked over one way or another. Cylinders are named according to their shape. So we could say that we have a circular cylinder. Now, a right circular cylinder would be a circle base on the top and bottom, and then a right angle for that lateral surface. Okay. An oblique circular cylinder is what's in the middle. So we got the circle bases, but then we got the kind of kicked over thing. The oblique cylinder they give there, what shape is that? I don't know, blob cylinder. You know, if it's something like an oval, I might call it an oval cylinder, but it's pretty much either circular or non-circular. All right, cones. The union of the line segments connecting a point P with each point of a simple closed curvature of the curve. Okay, whatever. Like I said, I'm trying to stick with what the book is doing to make it easy for you guys. It's not making it easy for me. You know what a cone is, right? Like an ice cream cone comes to a point. It's basically a smoothed out pyramid. Just like a cylinder is like a smoothed out prism. So a cone is just taking a pyramid and just kind of smoothing out those edges, right? Like imagine it's Play-Doh and you kind of smooth out those edges. So with a cone, we only have that one base, whereas a cylinder, we had the parallel bases. This one, we have one base, a point that's not in the plane of the base, and we have this lateral surface that is not line segments like it is for a pyramid. We got that lateral surface that rises between them. That's called the vertex. Now, if you called it the apex, we would totally understand. The right versus oblique, is the same as it was before. Right meaning right angle. The altitude or the height of the triangle is perpendicular to the base, so right angle. Oblique means it's kind of kicked over. All right, so that finishes section 11.4. This is a lot of just terminology. Okay. Stop presenting here. So there's just a lot of terminology in here. So don't be surprised if I ask you to do a lot of naming of these things and say, okay, what's the name of this shape? What's the name of that shape? You know, things like that. So We're going to be using some formulas for all of these in chapter 13. But okie dokie. Well, that concludes this section. I hope you enjoyed it.